test 13 chemistry paper discussion. Question number 26. So in this question it is mentioned that an atom made up of proton and a hypothetical particle double the mass of electron but having same charge as the electron is undergoing transitions from higher level to first excited level. So what will be the wavelength of the radiation emitted? So here we have a atom with one proton and revolving around the nucleus there is a hypothetical particle which has mass double that of electron. Okay, so here the question is what will be the wavelength of the radiation emitted when electron jumps from higher level, that is n is equal to 3 to n is equal to 2. Okay, so according to Bohr's theory, energy of electron in nth orbit it is equal to m e power 4 divided by 8 epsilon naught square h square into z square by n square. So here I can write this as hc by lambda. Then so 1 by lambda I will get m e power 4 divided by 8 epsilon naught square h cube into c z square by n square. Okay, so this term is nothing but RH, which is called Rydberg constant. Okay, so in calculating wavelength of the radiations emitted when electron jumps from one level to another level, so we use this formula 1 by lambda is equal to RH into 1 by n1 square minus 1 by n2 square. So this is the equation for electron. But in this case, the particle has double the mass of electron. Therefore, if I take this m as 2m for the hypothetical particle, the Rydberg constant will be 2RH, and 1 by lambda will be equal to 2RH into 1 by n1 square minus 1 by n2 square. I know that n1 is here 2 and n2 is 3. So substituting, you get here 1 by lambda is equal to 2RH into 1 by 4 minus 1 by 9, which is equal to 10RH divided by 36. Okay, so finally the lambda will be equal to 36 divided by 10RH, which is 18 divided by 5RH. So the correct option will be option C. Among the isomeric amines, select the one with lowest boiling point. So here in this question, option A, B and D, these compounds have hydrogen attached to electronegative nitrogen atom. So in these compounds there will be hydrogen bonding, and due to hydrogen bonding the boiling point will be higher. Whereas in option C, there lacks hydrogen attached to electronegative atom. So here there will be no hydrogen bond, hence the boiling point will be least. So the correct option will be option C. If lambda naught and lambda be the threshold wavelengths and wavelength of incident light, velocity of photoelectrons ejected from the metal surface is. Suppose we have a metal surface like this, and a radiation of energy hc by lambda is incident on it. So some part of the energy, that is hc by lambda naught, is utilized in ejecting electron, and remaining energy is manifested as kinetic energy of the electron. So I can write this as hc by lambda is equal to hc by lambda naught plus 1 by 2 mv square. So now 1 by 2 mv square will be equal to hc by lambda minus hc by lambda naught. Okay, now I take this hc common, I get hc into 1 by lambda minus 1 by lambda is equal to 1 by 2 mv square, and v square will be equal to 2hc divided by m, and I will write this as lambda naught minus lambda divided by lambda into lambda naught. Okay, so finally this V will be equal to 2hc by m lambda naught minus lambda divided by lambda into lambda naught and root over. So the correct option will be option C. This reaction gives best yield at, so here the reaction is between aldehyde and amine to give imine. So generally aldehydes react with nucleophiles under acidic conditions. Under acidic condition, what happens? This oxygen gets protonated, therefore the electrophilicity of the carbon, here the positive charge on carbon increases, so it gets easily attacked by the nucleophile. So in this case, here the base is the nucleophile is a amine. Okay, so if we use very low pH, then the hydrogen concentration will be very high, and the amine under the acidic condition get protonated and convert into RNH3 plus, that is salt. So to prevent this, what we do, we use moderate pH of 4 to 5. So under this moderate pH, so some amine will be remaining as free form, so which act as nucleophile and gives the desired reaction. So the correct option is moderate pH 4 to 5, option B. The correct set of quantum numbers for the valence electron of atom Z is equal to 36 is. For an atom with atomic number 36, its electronic configuration will be 1s2 2s2 2p6 and 3s2 3p6 3d10 4s2 4p6. It is a noble gas element. So here the last electron is in the 4p subshell. Okay, so this is the 4p subshell. So its n value will be 4 and its L value will be, for a p orbital L will be 1 and ml value will be -1 0 plus 1, any value we can take, and ms value will be plus half or minus half. So the correct option is option A. So 4 1 minus 1 plus half. Which of the following processes is exothermic? So here in option A, so there is a removal of electron from O plus ion. See, removal of electron, this is a energy absorbing process. So this is a endothermic process. So again in option B, O minus combine with one electron to form O minus 2. So here also it is a endothermic process, because here the negative charge on the oxygen repel with the incoming electron. Therefore this is a endothermic reaction. In option C, neon combining with one electron to form Ne minus. So Ne has a stable noble gas configuration. Therefore it does not accept electron easily. Therefore it is also an energy absorbing process, that is endothermic process. In option D, the sulfur combined with one electron to form S minus. So here this electron gets stability by interacting with the positive charge of the sulfur atom. Therefore overall energy of the system decreased and energy is released in the form of heat. So it is a exothermic process. Correct option is D. Which of the following properties of 1A group metals increases down the group? So here metallic character increases down the group, ionic radius increases down the group, melting point decreases, density increases, ionization potential also again decreases. So the correct option is A, B, D. See here for option C, melting point. Melting point is the temperature at which the solid converts into liquid. Okay. So melting point depends upon the nature of interactions between the adjacent to metal atoms. When the size of the metal is very large, the interactions between the atoms will be weaker. Therefore, melting point will be lesser. Okay. Similarly, when it comes to density, option D, density. Density for a density down the group, as the size of the nucleus increases, the volume of the atom does not increase proportionately. Therefore, density increases. So, the correct option will be option B only. What is the correct order of ionic character in the following? According to Fajans rules, covalent character of a bond is directly proportional to polarizing power of the cation. Polarizing power of cation. And polarizing power of cation is directly proportional to 1 by size. Okay. So here we have beryllium, which is smaller in size, and barium, which has larger in size. So when one Cl minus approach both these ions, due to strong polarizing ability of beryllium plus, the Cl minus electron cloud is distorted strongly. So this will get more covalent character. So here, since the polarizing power is inversely proportional to size, the barium has less polarizing power. Here electron cloud of Cl minus is distorted to less extent. Therefore, it will have most ionic character. Therefore, the correct option is the ionic character will be highest for barium chloride and least for beryllium chloride, option C. Which electronic configuration of element has abnormally high difference between second and third ionization enthalpy? High difference in ionization energy is observed when the element attains stable noble gas configuration. Stable noble gas configuration. So in option D, for example, you take 1s2, 2s2, 2p6, 3s2. After losing one electron, so this will convert into 1s2, 2s2, 2p6, 3s1. After losing the second electron, this will convert into 1s2, 2s2, 2p6, which is a stable noble gas configuration. So therefore, the removal of the third electron to get 1s2, 2s2, 2p5 will be very difficult here. Therefore, there will be a large difference between second and third ionization enthalpy. So the correct option will be option D. The total energy associated per quanta with light of wavelength 600 nanometers is. We know that energy of a radiation will be equal to Hc by lambda. So here H will be equal to 6.6 into 10 to the power minus 27 erg seconds into C is 3 into 10 to the power 10 centimeter per second. So since we are taking energies in x, so the distance should be taken in centimeters. Divided by lambda, again it is 600 into 10 to the power minus 7 centimeters. So here we can cancel some of this. So centimeter get cancelled, second and per second get cancelled. So again 10 to the power minus 7 and 10 to the power 10, it will be 10 to the power 17, and just 10 to the power 17 cancel with 10 to the power minus 27 to get 10 to the power minus 10. And again, so I have here 6.6 into 3 into 10 to the power minus 10 divided by 600. So this will be cancelled for 200, and again this will be cancelled for 3.3 by 100. So I have finally 3.3 into 10 to the power minus 10 divided by 100, which is equal to 3.3 into 10 to the power minus 12 eggs. So the correct option is option 26. An atom has mass 0.02 kg and its uncertainty in its velocity is given. And what is its uncertainty in position? So according to Heisenberg's uncertainty principle, delta x into m delta v is equal to or greater than h by 4 pi. So now we need delta x. This will be equal to h by 4 pi into m delta v. So I can substitute the values here. So h is 6.6 into 10 to the power minus 34 divided by 4 into 22 by 7. So I write 7 here into mass is 2 into 10 to the power minus 2 into uncertainty principle 9.2 into 10 to the power minus 6. So here I get 4 into 22 as 88, and this will cancel for with 6.6 with 11. So I get this 8 and this will be 0.6. Again this 2 will cancel 0.6 for 0.3. So here I have 0.3 into 7 into 10 to the power minus 34 divided by 8 into 10 to the power minus 2 into 10 to the power minus 6, that is 10 to the power 8. So that 9.2 into 10 to the power minus 8. Okay. So this will be equal to 2.1 into 10 to the power minus 34 divided by 8 9 is 72 16 73.6 into 10 to the power minus 8. So this 8 10 to the power minus 8 cancel with 10 to the power minus 34 for 10 to the power minus 26. So here I have 2.1 into 10 to the power minus 26 divided by 73.6. So I write this as 210 into 10 to the power minus 28 divided by 73.6. So this exactly cancel for 2.85. So I have 2.85 into 10 to the power minus 28 meters as the answer. So the correct option is A. Mostly studied characteristic X-ray spectra of elements. The graph which represents his observation is, according to Moseley's law, so the frequency of the radiation that is emitted, it is related to atomic number as it is equal to A into Z minus B. Okay, so the correct option is option A. So two statements are mentioned. We have to identify which is correct and which is wrong. So SO2, 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 H2O. Here both the central atoms, sulfur and oxygen, have 6 valence electrons. So in SO2, out of 6 valence electrons, 4 are involved in bonding with oxygen and 1 will be lone pair. And similarly in oxygen, out of 6, 2 are involved in bonding and the remaining 4 will be 2 lone pairs. Okay, so the statement 1 is correct here. Both have V shape because of the presence of the lone pair of electrons. So when it comes to statement 2, the bond angle of SO2 is less than that of H2O. So bond angle is inversely related to number of lone pair of electrons on central atom. So when there are more number of lone pairs, the bonds come closer and bond angle decreases. Therefore SO2 has more bond angle than H2O. Therefore second statement is wrong. Consider the following statements. So the first statement is NF3A has a trigonal planar structure. So out of 5 valence electrons of nitrogen, 3 will be bonds and 1 is lone pair. So it has pyramidal structure. So the first statement is wrong. Bond length of N2 is shorter than O2. So in N2 the bond order is 3 and in O2 the bond order is 2. So as the bond order is more, the bond length will be lesser So the statement 2 is correct only. C. Isoelectronic molecules or ions have identical bond order. So according to MO theory, isoelectronic species will have same bond order. So this is also correct. So option D, dipole moment of H2S is higher than that of water. In H2S, the dipole moment will be lesser than that of water because the oxygen is a more electronegative element. So here the correct statements are option B and C. So the correct one is A. The product A and B formed in the following reaction schema respectively. So when benzene is treated with HNO3 in the presence of H2SO4, this is called nitration mixture. We get nitrobenzene. So when nitrobenzene is treated with tin plus HCl, this is a reducing agent. It converts NO2 to NH2 group. Okay. So when aniline is treated with NaNO2HCl at 0 to 5 degrees centigrade, it will convert into diazonium salt. Okay. So this diazonium salt is a good electrophile. Okay. And it reacts with activated aromatic compounds such as phenols to give azo compounds. So when it is treated with phenol, so the phenol will attack this azo compound at the para position to give it will attack with this diazonium salt at para position to give azo compound, that is option B. So here the A is this aniline and the product B is this azo compound. So correct option is A. Sugar which does not give reddish brown precipitate with Fehling's reagent is, see, substrates which have free CHO group, they react with Fehling's reagent to give reddish brown precipitate. So let's see one by one option. So maltose has this formula CHO, CHOH, and the rest we have different number of OH groups. So here it has CHO free, so therefore it react with Fehling's reagent to give reddish precipitate. Second option, glucose. So glucose and maltose are epimers. They have same structure, they differ in configuration at only one carbon. So here glucose also has the free OH group, so it will also give positive test with Fehling's reagent. Similarly, C, lactose is a dimer. It is a dimer of galactose and glucose. Okay. So galactose and glucose, they are connected by one and fourth carbon. So the CHO of galactose and here CHOH and CHOH and CH. So here these two are connected by 1 and 4 positions. So in galactose the first position is not free, but in glucose the first position is free here. So this CHO will react with Fehling's reagent to give positive test. Okay, in option D, in sucrose, it is a dimer of glucose and fructose. So in this molecule, the glucose molecule and the fructose molecule, they are connected by 1 and 2 positions. So here both CHO group and CO group are not available for reaction with Fehling's reagent. So it does not give positive test with Fehling's reagent. So the correct option is D. The energy of electron in the ground state of helium plus is minus x joules. Then that of the electron in n is equal to 2 state for beryllium 3 plus is. See here, energy of electron in nth orbit, it is equal to minus 2.18 into 10 to the power minus 18 z square by n square. So for helium ion, for n is equal to 1, energy of electron is equal to 2.18 into 10 to the power minus 18. Its atomic number is 2, so it is 4 divided by 1. So according to the question, this is minus x. So for beryllium 3 plus, when n is equal to 2, so its energy will be equal to minus 2.18 into 10 to the power minus 18 into its z value is 4, so it is 16 by n is 2, so n square is 2 square, so 4. So I have same thing here also, minus 2.18 into 10 to the power minus 18 into 4. So this will also be minus x only. So the correct option is A. Arrange the following elements in increasing order of first ionization enthalpy. See, generally ionization energy increases from left to right. So here from lithium to beryllium, boron, carbon, nitrogen, ionization energy should increase, but there will be an exception with the beryllium. So here beryllium will have higher ionization energy than boron. Because in beryllium the electronic configuration is 1s to 2s2, in boron it is 1s to 2s to 2p1. So in beryllium the electron should be removed from the 2s orbital, which is closer to nucleus. In boron the electron should be removed from 2p orbital, which compared to s orbital is far from the nucleus. Therefore more energy is required with beryllium. So here the order will be lithium, then we will have boron, then beryllium, then carbon, and highest will be nitrogen. So the correct option will be option A. Identify the basic amino acid from the following. So here you should know the structures of the amino acids. So option A, tryptophan it is H2N CHCOOH. So this is CH2. So you will have a 5-membered ring attached to 6-membered ring. Okay. So here this is a neutral amino acid. It is not a basic amino acid. So basic amino acid is the one which has 2 basic functional groups. So there is only one amino group here, so it is neutral only. Similarly, option B, threonine. So threonine is H2N CH COOH CHOH CH3. So this is also neutral amino acid only. C, phenylalanine. This is H2N CH COOH CH2 phenyl group. This is called phenylalanine. So here also there is only one basic amino acid. It is also basic amino group. It is also neutral. Option D, histidine. It is H2N CH COOH. So CH2 thrice. So here you get CH2 CH2. This is connected to nitrogen, which is again connected to carbon having NH group and NH2 group. So this is a basic functional group. This is called guanidine group. So due to presence of 2 basic functional groups, this amino acid will be basic. So correct option is D. Which one of the following compound does not react with acetyl chloride? Generally, amines having at least one hydrogen attached to nitrogen. That means when an amine has at least one hydrogen, this will react with acetyl chloride CH3 C double bond O Cl. So here nucleophilic attack takes place to give an intermediate like RNR. So here there is a H will be positive charge on nitrogen, then O minus Cl CH3. Okay. So here this intermediate, it has 2 choices. it can expel one chlorine to give rise to amide product, or it can expel nitrogen to give back the starting material. Okay, so as long as there is a positive charge on nitrogen, this part will be a good leaving group, and always the reverse reaction is preferred. So here, when in this particular case, another molecule of amine acts as a base, removes this hydrogen as RNH3 plus. Okay, so after this step, you will be getting RNR CO minus Cl CH3. So now this Rn2 group, R2N group is a poor leaving group. So here this O minus will expel chlorine to give rise to R2N C double bond O CH3, that is the amide product. So this presence of hydrogen is very important for the reaction to move in forward direction. Okay, so in the case of option C, there is no hydrogen attached to nitrogen. Therefore, this reaction move in the reverse direction and only starting materials are favored. Option is C. The number of species from the following which have square pyramidal structure is. So here PF5 has a trigonal bipyramidal structure. BrF4, bromine has 7 valence electrons, minus charge means 8. Out of 8, 4 will be involved in bonding with fluorine atoms, and the remaining 4 electrons will be 2 lone pairs. So this is square planar structure. So this is also not the answer. IF5 with 7 valence electrons on iodine, it will be bonding with 5 are involved in bonding with fluorine, and 1 electron pair is as a lone pair. So this is a square pyramid. So this is one option. And BrF5 also has same structure as IF5. So this is also square pyramidal. And XeO4, xenon has 8 valence electrons. Out of 8, 2 are involved in bonding with fluorine, 2 are involved in bonding with oxygen, 4 are involved in bonding with fluorine, and one is lone pair. So this is also square pyramidal. And ICl minus will have same structure as BrF4 minus, that is square planar. So this is not the option. So the correct number of structures are having square pyramid is 3. The number of atomic orbitals from the following having 5 radial nodes each. Number of radial nodes is equal to n minus L minus 1. So for 7s orbital, it is 7 minus 0 minus 1, 6. So for 7p orbital, it is 7 minus 1 minus 1, that is 5. So for 8p orbital, it is 8 minus 1 minus 1, that is 6. And for 8d orbital, 8 minus 2 minus 1, that is 5. So the number of orbitals having 5 radial nodes is total 2. The number of electrons present in all the completely filled subshells having n is equal to 4 and s is equal to plus of each. If n is equal to 4, so the total number of electrons that can be accommodated is 2 into 4 square. So that is 32 electrons. Out of 32, 16 will be having plus of spin and 16 will be having minus of spin. So the correct answer is 16. Number of spectral lines obtained in helium spectra when electron makes transition from 5th excited state to 1st excited state is. So here we have an atom, and in this atom the electron is jumping from n is equal to 1, 2, 3, 4, 5, 6. So 5th excited state means level 6, and it is jumping from 1st excited state, that is 2. So the number of spectral lines will be equal to delta n into delta n plus 1, divided by 2. So here delta n is 6 minus 2, that is 4. So that is 4 into 4 plus 1 divided by 2. So this is 20 by 2. So the number of spectral lines is 10. The number of electrons. So it does not have odd electron. And O2 minus has 17 electrons. So it will have one unpaired electron. And NO 7 plus 8, total 15 electrons. So it will have one unpaired electron. And Cn minus, so this is 6 plus 7 plus 1, total 14 electrons. So it does not have unpaired electron. O2 minus 2, so this has 18 electrons. So it does not have unpaired electron. So the correct answer is 2.